Imagine holding a lump of charcoal. It's gnarled, brittle, and completely black. Now imagine being told that this lump of charcoal is actually a book, written 2,000 years ago in a Roman city, and that your job is to read it without it crumbling to dust. For centuries, this wasn't a thought experiment. It was the impossible reality for historians staring at the scrolls of Herculaneum, a city buried by the eruption of Mount Vesuvius in 79 AD. Any attempt to unroll these carbonized papyri meant destroying them. But today, thanks to a revolutionary fusion of high-powered light and artificial intelligence, we are finally reading the unreadable. This is the story of digital unwrapping, a technology that is peeling back the layers of time to resurrect the lost voices of the ancient world. In 1752, a farmer digging a well near Naples, Italy, stumbled upon a magnificent Roman villa, believed to belong to the father-in-law of Julius Caesar himself. And inside, an incredible discovery, the only intact library to survive from the classical world. But there was a catch. The nearly 1,800 papyrus scrolls had been baked by the intense heat from Vesuvius, turning them into blackened, fragile cylinders. It was a maddening paradox. A library preserved for millennia, yet utterly inaccessible. Early attempts to read them were disastrous. One method involved slicing the scrolls in half to copy the text from the exposed layers, a process that destroyed the very thing they were trying to save. Later, a monk named Antonio Piaggio invented a machine to painstakingly unroll the scrolls, but it was slow and often caused the brittle papyrus to shatter. While some works by the philosopher Philodemus were recovered, the vast majority of the library remained a silent, tantalizing mystery. The fundamental problem was the ink. Roman scribes used a carbon-based ink, essentially soot mixed with water. The scrolls themselves were now carbonized papyrus. So you had carbon ink on carbon paper. In an X-ray scan, the ink and the paper have almost the exact same density, making the text completely invisible. It was like trying to read pencil on a sheet of black paper in the dark. For decades, it seemed like an insurmountable challenge. The first real crack in this ancient code came not from Herculaneum, but from the shores of the Dead Sea. In 1970, archaeologists found a similarly charred lump of a scroll in the ancient synagogue at En-Gedi, which had been destroyed by fire around 600 AD. For over 40 years, it sat in storage, unreadable. This is where Professor Brent Seals, a computer scientist from the University of Kentucky, enters the story. Seals and his team had been developing a technique called virtual unwrapping. First, they scanned the scroll with X-ray microcomputed tomography, or MuCORT. This takes thousands of X-ray images from different angles to build a high-resolution 3D model of the scroll, revealing all its crumpled and folded inner layers. The next step is called segmentation. This is where the magic begins. Using custom software, the researchers meticulously trace each individual layer of the scroll within that 3D model, creating a digital version of each page. Then comes the texturing, the hunt for the ink, and with the En-Gedi scroll, they had a lucky break. The ink wasn't carbon-based, it contained metal, likely iron or lead. This metallic ink is much denser than the parchment, so it showed up as bright, shining pixels in the X-ray scans. Seals' team developed algorithms to find these bright spots on the segmented layers, revealing the hidden text. Finally, these textured layers are digitally flattened, turning the curled pages into flat, readable 2D images. The results were breathtaking. The virtually unwrapped text was a copy of the Book of Leviticus, dating to the 3rd or 4th century AD. It was the earliest copy of a Pentateuchal book ever found in a holy ark, a landmark discovery. It was proof that the most severely damaged scrolls could be read without ever being touched. This success set the stage for tackling the ultimate prize, the carbon ink scrolls of Herculaneum. Brent Seals and his team knew the carbon ink of Herculaneum was the real challenge. They needed more power. So they took the scrolls to synchrotron light facilities, massive particle accelerators that can produce X-ray beams billions of times brighter than those in a hospital. With this incredible power, they started to see it. Faint, subtle differences in the texture of the papyrus where the ink was. The signals were almost imperceptible, but they were there. The question was, how do you find those faint signals reliably across an entire scroll? The answer was artificial intelligence. The team began training machine learning models on scans of already opened Herculaneum fragments. They taught the AI to recognize the unique, subtle signature of the carbon ink in the high-powered X-ray data. To supercharge this effort, in March 2023, SEALs, along with Silicon Valley entrepreneurs Nat Friedman and Daniel Gross, launched the Vesuvius Challenge. It was a global competition with over $1 million in prize money for anyone who could successfully read the scrolls from the high-resolution scans SEALs' team had made public. The response was explosive. A global community of computer scientists, AI experts, and students downloaded the massive datasets and got to work. In late 2023, the first breakthroughs came. Luke Ferrator, a 21-year-old college student and SpaceX intern, won the first letters prize by identifying the Greek word porphyra, which means purple. He proved it could be done. A few months later, Yusuf Nader, an Egyptian PhD student in Berlin, successfully read several columns of text, pushing the boundaries even further. The climax arrived in February 2024. The grand prize was awarded to a team combining the talents of these two pioneers, Ferrator and Nader, along with Julian Schilliger, a Swiss robotics student who had made crucial advances in the segmentation software. Together, they had done the impossible. They had deciphered over 2,000 characters from a previously unread Herculaneum scroll. For the first time in nearly 2 millennia, a lost work from the ancient world was being read. And what did it say? It was a philosophical text from Philodemus, the villa's resident philosopher, discussing the nature of pleasure, touching on subjects like music, food, and the senses. It was a brand new window into the intellectual life of the Roman world, opened not with a scalpel, but with code. So how exactly does this magic trick work? The technology is a pipeline. It starts with the scans from a synchrotron, which are sensitive enough to detect minuscule density variations between the papyrus fibers and the carbon ink, which might also contain trace amounts of lead that help it stand out. Once you have that massive 3D scan, the computational work begins. The first problem is geometry. You have to digitally separate the tightly wound, crushed, and distorted layers. This is segmentation. Vesuvius Challenge winner Julian Schilliger developed a tool called the volume cartographer that was instrumental here, allowing researchers to meticulously map these complex surfaces in 3D space. The next and most critical step is ink detection. This is the AI's job. The winning team used a suite of powerful deep learning models, including a type of neural network called a timesformer. These models were trained on known text from open fragments to learn to spot the faint signature of ink. They scan the 3D data and essentially paint on the text where they detect that signature. Finally, once the ink is identified on the 3D layers, an algorithm computationally flattens these surfaces, turning them into the 2D images of text we can all read. This intricate dance between advanced imaging, complex geometry, and powerful machine learning is what makes it all possible. The impact of this technology extends far beyond burnt scrolls. Consider the historical practice of letterlocking, where, before envelopes, people would intricately fold and secure a letter so it became its own security device. To read these letters, historians traditionally had to cut them open, destroying the very folding patterns that are a valuable part of their history. Now, researchers at MIT are using the exact same X-ray and virtual unwrapping pipeline to read these letters without ever breaking their seals. They digitally unfold the letters, revealing their contents while preserving the physical object. They've read a 17th century letter from a man named Jacques Sénac. asking his cousin for a certified copy of a death notice, a mundane request that proves a revolutionary capability. The power of AI is also being used on other historical documents. Deep learning models can restore faded text on palimpsests, manuscripts where the original text was scraped off and overwritten. A system called Ithaca, developed by DeepMind, can not only restore missing text in ancient Greek inscriptions but also identify their geographical origin and date them with stunning accuracy, improving a historian's restoration accuracy from 25% to 72%. This is not about replacing historians, it's about giving them superpowers. It's about creating a partnership between human expertise and machine intelligence to accelerate discovery. The journey of digital unwrapping is just beginning. The majority of the Herculaneum scrolls are still waiting to be read. They could contain lost plays by Sophocles, forgotten histories by Livy, or entirely new philosophical traditions. And archaeologists believe the main, larger library of the villa, which would have held a wider range of texts, hasn't even been excavated yet. When it is, we will have the tools to read it. We are entering a new era for the humanities, one where the silence of the past is being broken. Charred scrolls and locked letters are beginning to speak again, their voices resurrected by powerful beams of light and the logic of artificial intelligence. The past, it turns out, has a very bright future.